Good day, grade 10 optics students. Today what we're learning about is the ray model and reflection. Specifically, we're going to answer this question. How does light reflect off of different objects? Well, we know how color gets absorbed or subtracted, but now we're going to learn about how light reflects. Specifically, we're going to talk about a special law called the law of reflection. So, in order to do this, we have to know what the ray model is, and we know this already. We know that light travels in straight paths. We know an arrow can be used to show the path that it's going to take and the light energy that it takes. Okay, so if we take a look, this, just a straight line, I should have used my ruler, oops, that is a light ray. A beam is multiple parallel rays. So if I got multiple parallel rays, that means that they're going in the exact same direction. That's a beam of light. Well, a light ray is a single one, a beam is multiple rays. So for example, if we take a look at our item here, we have an apple, the light leaves the candle. If our eye is up here, okay, ooh, beautiful eye, we can see the light rays leaving the candle, hitting the apple, and eventually moving all over the place. So you can see here our light is hitting this apple and leaving in multiple directions. If you take a look, this a wiggly arrow here shouldn't exist because light travels in straight lines. That shouldn't be happening. Unfortunately, my hand isn't that steady, but any light that hits our eye travels in straight line from the candle, hits the apple, then hits our eye. Okay. I also need us to remember a few things here. We got to remember that there's three different categories of objects in terms of how much light they transmit. Transparent means that light goes right through and none gets stopped at all. Translucent means only some stuff goes through, like frosted glass. And opaque means no light goes through. You can stop that and record that if you don't have that memorized. So let's define reflection. Reflection is the bouncing back of light energy from a surface that it was projected on. What objects actually reflect light really well? Well, you know one, a mirror. Now a mirror is actually a piece of glass with a thin reflective film on it. So this little surface here is a thin reflective film, and on the other end you have glass. That's why it shatters if you break it. Now the scientific symbol for a mirror is by drawing a line, just like so, and then drawing hashtags here. I know that's not really hashes, hashtag, not hashes. And you can see that this is the side of the mirror that's reflective. Okay, so the straight line down is the reflective side. So from now on, if we draw a mirror, this is how we're going to draw it. And the light ray would come from this side to hit the mirror to reflect. So here's some terminology we need to know for reflection. So the first thing that we need to know is incident ray. Incident ray is the ray that is approaching the mirror. A reflected ray is the ray that bounces off that mirror. Okay, so you got an incident ray going in, a reflected ray coming off. The point of incident is where that incident ray hits and the reflected ray leaves. The normal is going to be a 90-degree angle to the surface of the mirror. The angle of incidence, which we'll talk about in a second, you'll be able to understand, is the angle between the incident ray and normal. And the angle of reflection is really the angle of reflection and that normal. So let's take a look at this ray here. Let's label everything. So first of all, this ray going in, the arrow shows the path. So this light is coming in here. So that means that this is our incident ray. And you can see that it's bouncing off in this direction here. This is our reflected ray. Okay? The next thing that we need to know is you can see that there's a 90-degree symbol. This is our mirror down here. And this is a 90-degree angle up to this point right here. This is known as our normal. Oops, didn't mean to put that in there. So that's our normal. It's 90 degrees off the surface of the mirror. And that means that between the normal and the incident ray is our angle of incidence. Okay? So incidence means it's occurring first. So angle of incidence. And here we have our angle of, you guessed it, reflection. So the law of the reflection is this. The angle of incidence is always equal to the angle of reflection. And the incident ray, reflected ray, and normal all lie on the same plane. This means that this angle that I've circled here, the angle of incidence, is always equal to the angle of reflection. So if you think about pool, the angle that you go in at is always going to be the angle that you go out at. So I don't know if you play pool, but if you play billiards, again, it follows the angles that you would think about how reflection would occur. We're going to talk more about what the plane means, because that probably is going to be confusing to you. I don't mean the same airplane, I mean on the same surface. So we'll talk about what that means. So we have different types of reflection. One type of reflection, is specular reflection. Really, the type of reflection depends on the surface. Smooth surfaces will bounce off parallel beams. So this means that if you have an image here, like you have a nice lake there, you can see that the lake is perfectly reflected into the water. Now why is that? Because the water is smooth as glass. And because it's smooth, all the light rays bounce off in a manner that's perfect. Now diffuse reflection is less perfect reflection, and that's because you can see the light rays are all coming in parallel to each other here, but when they leave they bounce off in crazy different directions, and that means it kind of obscures the image. So we can't see on a rough wavy day, you can't really see the image that's reflected off the surface. Now we have two types of images. The first type of image that we have is a real image, and this is what we're going to talk to. It can be formed on a screen. So we want to write this down. I'll give you a note to summarize this, but it can be formed on a screen. A virtual image does not actually arrive and will come from a different location. So a real image can be formed on a screen. A virtual image cannot be formed on a screen. What we're going to notice is that a real image from our labs will always appear inverted. A virtual image will always remain upright, cannot be formed on a screen.